Students, today we'll learn about quadratic modeling. Now, in our day-to-day life, many things can be modeled as a quadratic function. Take, for example, a ball is projected from the ground by making certain angle to the ground. It will follow a parabolic path, which is quadratic function. So, its height from the ground can be modeled as a quadratic function of the time. So let us see one problem here. So this is a past paper type question I'm putting here. Yes, so this is the question. A ball is projected from a certain height from the ground. The height of the ball is modeled as a quadratic function of time t. And keep it in mind that the ball is not projected from the ground but from a height, certain height above the ground. So in the first case, you have to find out the height from which the ball is projected, the height above the ground. So the height above the ground from which the ball is projected and that is nothing but the initial height of the ball. That means the height of the ball at time t is equal to 0. So in your quadratic function, put t is equal to 0, which is 20 into 0 minus 10 into 0 square plus 19. That comes out to be 19. That means the ball is projected from a height of 19 meter above the ground. Now come to part B. You have to predict the time at which the ball will hit the ground. Now, when the ball hits the ground, that means it is on the ground. So obviously its height from the ground will be 0 meter. That means I'll equate h of t to 0. So that will give 20t minus 10t square plus 19 equal to 0, or 10t square minus 20t minus 19 is equal to 0. I have shuffled the terms and changed the sign to make the t square coefficient positive. But obviously this is not a factorizable quadratic, so I will go for the formula method. A is 10, B is negative 20, C is negative 19. So T is equal to minus B plus or minus root B square minus 4AC upon 2A. Don't get confused. Here the variable is t, so roots will be in terms of t, not x. So minus b, that is negative of negative 20 plus or minus root b square, that is negative 20 the whole square minus 4, a is 10, c is negative 90 upon 2a, that is 2 into 10, which is 20 plus or minus. Now if you calculate this will be 400 plus 760 upon 20. Now I'm not going in much details of the calculations. You can directly do this on the calculator. So you'll get two values of t. One is 2.70 and other is negative 0.70. Obviously, negative 0.70 is not possible because time cannot be negative. So only acceptable value is 2.70. That means the ball hits the ground after 2.70 seconds after its projection. Now in C part, I have to write the quadratic in the form a minus b into t minus c the whole square. So ht is equal to 20t minus 10t square plus 90. So first I'll write it as minus 10t square plus 20t plus 19. I'm just shuffling the terms. Now I'm going to use the completing square method here. So I'll take t square and t terms together and take t square coefficient out so that inside the bracket t square coefficient will become 1. So I am taking minus 10 out. So this will be minus 2t here plus 19. Okay. So I will take t coefficient. Now instead of x coefficient it will be t coefficient divided by 2 and square it. So it is minus 2 upon 2 the whole square, that is 1. So minus 10 t square minus 2t. I will add 1 here. Now to balance, I have to add or subtract something, but be careful, I am adding 1 and outside the bracket there is minus 10. So actually I subtracted 10, so I am adding 10 here. Is that clear to you? Minus 10 into 1 when you open the bracket. So actually you subtracted 10. So to balance you add 10. So the bracket has become a complete square. So that is here t square. So write t here. Square root of 1 is 1. And only write the sign of the middle term. So t minus 1 the whole square. And 19 plus 10 is 29. Okay, so I will write this as 29 minus 10 into t minus 1 the whole square. So I have to compare this with a minus b into t minus c the whole square. So a is equal to 29 here. Negative b is negative 10. So b is 10. And negative c is negative 1. So c is equal to 1. And using this, I have to predict the maximum height reached by the ball and the time when this maximum height is reached. Now for that, what you do is take this particular form that you have got here, and you know that if y is in the form a into x minus h the whole square plus k, then the vertex is at hk. So in this case, what is the vertex? So compare here, negative h is negative 1. So h is 1 and k is 29. So the vertex is 1, 29, 1 comma 29. Secondly, here the t square coefficient is negative, negative 10. That means your parabolic graph is u opening downwards. So it has a maxima. So this vertex is a maxima here. And keep it in mind here that the y coefficient is the height, x coefficient is the time. That means the maximum height is 29 meter and it is reached by the ball after 1 second of projection. So because the t square coefficient is negative, you will have a u that is opening downwards and the vertex will be a maxima. So to make all these points clear, I will just put a graph here so that it will become more clear with you. So this is the quadratic graph. Here on y-axis, the height in meters is plotted, and on x-axis, time in second is plotted. Now here the y-intercept is 19. That means the ball is projected from a height of 19 meter above the ground. The vertex is 129. And as you can see in this graph, the vertex is a maxima. That means the maximum height reached by the ball is 29 meter and it is reached 1 second after the projection. And the x-intercept on the time axis is the time when the ball will hit the ground, that is 2.7 seconds. So is this concept okay with you, students? So I'm just giving you a very similar problem. Try it for homework. If you don't get it, please ask me in the next class. So this is what the quadratic modeling is. So this is a very similar type of question. Just try it at home. And in case of any doubt, please ask me in the next class. Your doubts are always welcomed. So see you in the next class, students. Enjoy the day ahead. Bye.